The National Student Solar Spectrograph Competition is the education and public outreach portion of the NASA IRIS mission. So the goals of the competition are to give undergraduate students at different types of universities an opportunity to build and demonstrate a ground-based solar spectrograph. So the format of the competition is more of a science fair type format than an engineering design competition, in that each team sets their own science goal and then they design to support that science goal. So the teams are judged in the 4 different categories: best build, best design, best science, and best presentation. We had 17 teams that showed up in Bozeman. They were from 8 different states, so we had a pretty good geographic distribution of teams from across the country. And it's good because it gives the students at those universities a chance to interact with other students who maybe wouldn't get that opportunity. So it's really kind of fun to watch when they all come to Bozeman and how they all work together on a science objective. The science objectives that the teams had, for example, MSU hotspots were studying the rotational shift of the sun by measuring and analyzing the Doppler shift of the sun. The Indiana team, theirs was an educational-based spectrograph to measure the concentration of potassium permanganate in water. Charleston, they were looking at differences between the spectra of sunspots and quiet regions of the sun. MSU redshift, they were detecting atmospheric water vapor using an inexpensive CMOS-based spectrograph. And MSU red haze, they were studying the scattering behavior of sunlight through samples of wood smoke, similar to that produced by wildfires. The typical student participant in the spectrograph competition is a STEM-based student, so science, technology, engineering, and math. They can be electrical engineers, mechanical engineers, computer science folks. They can be physics majors. They can be earth science majors. Really anyone that has an interest in a hands-on science project that is a little bit out of the norm.
I learned that nothing's as bad as it ever seems, and it's really worth it to do, just to try something new.
I learned about optics. I learned about how tough it is to make sure lights go in the right direction, to make sure that, I learned how lenses work. I learned what skills I have, what things I'm good at, what things I don't have as much fun with.
And I learned that it can be really fun. When you're just sitting and crunching numbers, it's not very fun, but then when you get to actually apply it and really, science with it, it's a lot of fun.
I think these competitions are highly relevant to motivating folks in the STEM fields. It gives them that hands-on, unique opportunity. It gives them a chance to tinker with things. It also gives them a chance to work on things that isn't for a grade, so it's outside their classroom experience. So it's a nice controlled environment, if you will, that they can fail in. And not that we set them up to fail, but you learn by your mistakes. And so I think it's an opportunity for the students to stretch themselves, to try something new, that it's okay if it doesn't work out 100%. But these competitions like this are very, very valuable in developing our future generations of engineers and scientists.